The topic of this section is Random Access Protocol. We will introduce two types of random access protocols this time. They are Aloha and CSMA. We first have an overview of this section. The characteristics of random access protocol is that all the stations compete using channel, which might result in collision. The typical random access protocol are Aloha protocols, which include pure Aloha and slotted Aloha, and different types of CSMA protocols, including CSMA/CD, which is used on Ethernet. The basic working principle of pure Aloha is to let users transmit whenever they have data to be sent. A sender can always find out whether or not its frame was destroyed by listening to the channel output. If the frame was destroyed, the sender just waits a random amount of time and sends it again. If time cost to transmit a sent frame is T, the dangerous period of collision in pure Aloha is 2T, because the frame can only be transmitted if and only if there is no other station sending frame during that 2T period. We're now going to introduce slotted Aloha protocol. In slotted Aloha, time is divided up into discrete intervals, each interval corresponding to one frame time. We are now going to introduce slotted Aloha protocol. In slotted Aloha, time is divided up into discrete intervals, each interval corresponding to one frame time. That means an interval is the time which is used to transmit a frame. A terminal or station is not permitted to send until the beginning of the next slot, also called as interval. As stations can only transmit frames at the start of each slot, collision can only be occurred at the very beginning of slot. Once a station competes successfully, and then no collision during that slot. For slotted Aloha, the collision period is one frame time T. A successful transmission requires no other frame to be sent during the period of T. Here comes Carrier Sense Protocols, CSMA, Carrier Sense Multiple Access. The significant characteristics is stations sense the channel before sending frame. It is an improvement of Aloha by sensing the channel before transmission. It reduces the chance of getting collided. We start from non-persistent CSMA. The basic idea of non-persistent CSMA is this. Step 1. A station sends the channel. If no one else is sending, then it begins sending. Step 2. If the channel is already in use, it does not sense it. Instead, it waits a random time and repeats step 1. The advantage of non-persistent is that waiting a random time can reduce the probability of collision, as it will possibly let each station start transmission at different time. The disadvantage is also caused by the random time waiting, as we don't know how much when the channel will be idle. During the waiting time, the channel might be idle. For one persistent CSMA, the working principle is different. Step 1. A station senses the channel. If no one else is sending, then it begins sending. This is the same with non-persistent. Step 2. If the channel is busy, the station waits and senses it continuously. When the channel becomes idle, it begins transmitting. Step 3. If collision is occurred, waits a random time and repeats. Based on one persistent CSMA, we are proposing P-persistent CSMA. The basic idea of P-persistent CSMA is this. Step 1. A station sends the channel. If no one else is sending, then it transmits with probability P and delays 1 unit time to transmit with probability 1 minus P. Step 2. If channel is busy, the station waits and sends it continually. Once the channel becomes idle, repeat step 1. Step 3. If a station has delayed its transmission 1 unit time, repeat step 1. So we can find P-persistent CSMA is similar with 1 persistent. We can regard 1 persistent as a special example of P-persistent, where P equals to 100%. After we finish the introduction to these CSMA protocols, think about one question. For 1 persistent CSMA, if a station sends its data after sensing the channel is idle, can a collision still be occurred? The answer is yes, because there are 2 reasons for the collision to be occurred. Reason 1, there might be 2 or more than 2 stations sending data at the same time, which we have explained it previously. Reason 2, the propagation delay might cause the collision. When the station sends the channel, even if it is idle, it does not guarantee no one else uses the channel. Some frame might be on the channel at that time. Just because of propagation delay, the station does not sense it. Although the propagation speed is quite high, which is about 200 meters per microsecond, it still takes time to propagate. CSMA/CD, which is the carrier sense multiple access with collision detection, considers the issue of propagation delay. The working principle of CSMA/CD. Step 1. A station sends the channel. If no one else is sending, then it begins sending. Step 2. If the channel is busy, the station waits and sends it continually. Once the channel becomes idle, sends the data at once. Step 3. If collision is occurred, aborts its transmission and waits a random time and repeat step 1. The characteristics of CSMA/CD is explained as follows. All stations receive signal of itself while sending. So the station detects a collision if signals are different. A station aborts its transmission at once. It detects a collision and sends a jammed signal in order to notify other stations when there is a collision. All stations need to wait for a random time to retransmit again. In the end of this section, we have 2 questions. Question 1. Think about what are the collision period for aloha and slotted aloha. Question 2. For CSMA/CD, what is the maximum amount of time for the sender to detect the collision? That's it for this section. Thank you.